Hello everyone, and welcome back to the second part of my Kaba Simplex 900 series. So today we're going to be talking about the differences between the door latch style, it's the gray on the left, and the deadbolt style, it's the one on the right. So besides the obvious, this one's a deadbolt, this one's a latch, there's a few differences in the mechanism and some options in the lock and sort of the way that those are implemented. So I'll get down to that. If we look on the back or the inside, we have on the gray door latch style this button, but on the deadbolt style, there's no button. So what does this do? Both of these have the latch here that you use to toggle the state of the door. So on the deadbolt, we can turn it in one direction, it retracts the bolt. We turn it in the other direction, the bolt extends. Here it's spring-loaded, on the deadbolt it's not, but on the door latch we bring the latch back. Note that the dead latch does not return. And you just bring it in and it pops back out. So what if you want to leave your door unlocked? Well, that's what this button is for. Call that an override button. You move the latch and then you push the button down, and now when you let go, the lock stays open. So that's just a very short little slide there, and then when you slide it forward, the lock pops back open again. On some models, this one included, you can also use it to lock the door from the inside so that the bolt's retracted already. Now there's no way to push the bolt in. This is sort of similar to how the dead latch works, but in this configuration, if someone's on the outside of the door and they input the correct combination, you actually cannot open the door. So it seems a little dangerous, but actually because you can't manually force the latch in either, the door can't actually be closed in this configuration. So you have to do something pretty convoluted to be able to actually lock everyone out and not have anyone on the inside. So I'm going to free that back up, and we'll flip back to the other side and talk about what's going on here. So for the sake of convenience, I've numbered what all these correspond to, although it doesn't super matter in this case. And I'm going to take, again, this is what's normally on the outside of the door, but it's a handy tool for toggling the latch in here. And I've set the combination of both of them to just 1. So you press 1, I take my latch, and I can turn it, and it's not retracting the bolt anymore. Interesting. Okay, well, sorry, that popped out. Oh. Alright, it's turning in the wrong direction. Okay, so I'm going to show you a little of how this lock works, sort of what happens when you're opening the lock from the outside, from the push button side. So I have, this little latch portion again. This is normally what's on the outside of the door. And I've set the combination of both of these to just 1. So I press 1, and then I turn the latch. I want to turn it in this direction. So there's some movement. It reaches this point and it starts to touch the bar. And we keep pushing and the latch retracts. And then we let go and the lock has reset itself internally. I don't think I talked about how that worked in the last video, but I'm sure I'll do it in the later one. So what exactly is going on there is we have this plate you can see down here, or alternatively, here's a standalone version. And then there's this bar with a pin in it. You can see the outline of the pin sort of around there, and that's extending into that groove in the plate. So the plate's moving some small distance, and then it hits the end of the travel and starts to actually push on the bar. And when you push on the bar, it retracts the bolt. And I'll show you what that looks like in just a second. But first, let's see what it does from the deadbolt side. So the deadbolt, Same exact thing. Press 1, take my latch, and, well, sorry, that was the reset direction. I press 1, and I open the lock. And now it actually stays in this other position where that arm is pulled all the way against the right side of that plate. So now if I turn it in the clear direction, it'll lock the lock. So here you can lock the deadbolt from the outside versus the door latch, which you can only, well, which locks itself basically. So now if I go to clear the lock again, I hit the end of the travel actually internally to the code block. So it's not pulling anything and it's not doing anything to the bolt. On the other one, same thing, that's the reset direction. I'm hitting an end of travel and nothing's happening. It doesn't do anything to the lock. So how it works from the inside, you can see when I move the latch in the back, that bar is still sliding. It's still sliding up. And the same thing over here, bar slides up when I unlock the door, slides back down when I lock the door. So that's just what happens, on the inside of the door. So now I'm going to pop these plates off and show you how this mechanism works internally. I'm going to start off with the deadbolt because that one's a lot simpler. So there's normally 2 screws that hold it on. I've already taken those off. And this is basically just it. So here's these 2 gears. They're linked together, and the top sort of follower gear has a spring on it. And that spring basically makes it so that it wants to be in either the left or the right position. Once it moves past the central line, it just kind of wants to pop to one or the other. It's a common feature in deadbolts, useful for making sure the bolt is either fully extended or fully retracted. It's pretty bad to close a door with a deadbolt partially extended. And you can end up in sort of weird situations if the bolt is almost but not quite extended or almost but not quite retracted, and it's just no good. So you can see again another pin moving in a groove, and that's all this mechanism is doing is just popping back and forth. And while it's doing that, it's moving the bar, which is attached to this smaller plate. And this linkage right here, this grooved shaft, is what ties into the latch in the door. So that is what allows you to manually actuate the door from the inside. And this bar is what links it to the code block and is what allows you to actuate the door from the outside. So all that's happening with this deadbolt right here, there's no springs or anything. All of that spring-loaded behavior is implemented in this plate and this whole geared linkage. And there's just the groove here, and that's that groove that this bar is pushing into. So there's not a lot really mechanically happening in here. There's just a pin that moves back and forth in a groove, and sometimes it moves out, sometimes it moves in. And the deadbolt itself, as I showed in the previous video, it's just got a couple ball bearings on springs to kind of keep it sliding nice and smoothly and keep it from rattling around too much. So moving that aside a bit and looking at the door latch, which is definitely the more interesting of the two. I can pop that open and show you what's going on with this. It's almost identical, except there isn't that spring on the tab. The reason is that the door latch itself has the spring, and that mechanism works a little differently, and there's no need to sort of snap it back into the open position. But it's the same thing. We have the little pin on the bar, and that slides back and forth and moves inside this plate and allows you to, well, allows you to clear the plate in one direction and allows the plate to actuate the door in the other direction. So let's look at what happens with the door latch and this other piece that we call the dead latch. So there's two main things going on here. The first is the simple door latch. It's not a whole lot to it. It's got, one rounded side, and that's the side that hits the door frame and retracts itself as the door closes, pops back open and catches. But you can see there's some complicated features in here. It may not be immediately clear why those are there? Well, first off, part of it is in this space. This is where this pin goes into, and that's what pulls the door latch in. And this groove over here, as we saw before, we have the override pin in the back. You can kind of see that here. And that override pin actually works on that groove. So when you push, when you push the override pin down, it gets in the way and catches on that groove. And when you've pushed it all the way in, the override pin will fall down into that groove again, and then it'll catch and it'll keep the door latch retracted. Now, if it doesn't make sense because that's on the other side and we're looking at the top right now, this whole mechanism is actually mirrored on each side, or I guess rotated 180. So you can install the door latch in either direction, up or down, depending on which way your door swings, and it's basically identical on each side. So we'll slide that back in, and we'll look a bit at how the dead latch works. The whole assembly mounted up on a block. If you're wondering why, it's because my camera mount isn't exactly adjustable. So I want to look at some of the finer details of what's happening with the dead latch. If you're not familiar with what a dead latch is, it's a way that keeps the door from being forced open. If you've ever seen in the movies or anything like that, this sort of open a door with a credit card trick, what they're doing is, so normally this doesn't fully extend quite that far because the bar or the pin prevents it. So this is about the farthest that the door latch normally extends. Now, if you took something flat, here I've got, a piece of steel, but normally it'd be a credit card or something, and you push it in that gap, you normally have the door jamb on your right side, and you have the lock on the left, and so if you just push it straight down, you can force the lock back, right? Well, the dead latch is meant to prevent that. So the dead latch is this little triangle piece down here, and when we push that in, we can't retract the door latch anymore. If we let it go, the door latch retracts freely. Now, if you're wondering quite how that works, it's because the plate that the door latch catches into is only large enough to catch the door latch itself, and is not large enough to catch the dead latch. If you cut it out, as is sometimes done by people who don't understand these, then you'll disable the dead latch and you'll make it no longer capable of preventing this type of attack. Same thing happens if the door is gapped too wide, or any number of other ways you can improperly install a door or a lock in a door. This one is actually pretty immediately responsive. Some dead latches on doors will have to go almost all the way in order for them to work. This one only has to go in maybe like halfway, maybe a little more. So the main way that this is working is when I push the dead latch in, it prevents this bar over here from retracting. So normally if I push the latch in, it pushes that bar down and out of the way. And that bar isn't really seen to do much. But when I push the dead latch in, we see this whole little piece of sheet metal that's attached to the dead latch also slides with it. And this sheet metal has a little bent piece up here. It's called the lance. And it moves into this groove in this plate. So when we insert that flange, we can no longer remove or retract the door latch because it's hitting the plate, and the plate can no longer deflect downwards. If you're wondering what all this extra business is with this plate and the mounting and what this spring doing back here, basically all that anything is doing in this whole assembly is providing restoring force, like this spring, the spring in here that pushes the dead latch forward, or like this tab and this spring, it's keeping things aligned. So this is a mechanism that prevents the door from opening unintentionally, or prevents the door from This is a mechanism that prevents the door from being forced open, but in doing so, it prevents the door from opening at all. This is a mechanism that prevents the door from opening due to certain types of attacks. So there's definitely some possibility there that if something got bent, something was out of place, something like that, you would wind up in a situation where the door doesn't work at all. This would be almost as bad as the door not locking. So they have these extra flanges, this spring, all that. It's mostly just there to keep everything smooth and keep everything running in the track that it's supposed to. Otherwise, these things might pop up, or they could come out, and the lock would jam up very, very quickly. So that's about it. There's not a whole lot to these mechanisms, but they are pretty important. The dead latch does do a lot to make sure that you can't force these doors open, especially a door like this has a lot going on that might open up the jam, or the gap between the door and the door jam, and would allow for those kinds of credit card attacks, which is why it has this dead latch, why all doors should have that, really. And the deadbolt, as we saw, is a pretty simple design. It's not a whole lot going on there. If you're wondering why the cases look the same, even though the deadbolt doesn't need all this business going on down here, basically, it's just easier to manufacture that way. These are cast parts, so they only have to make one mold. There's no sense in making a different mold. So I think that wraps this up for this video. I think the next video that I'm going to do the attack on the outside of the door, how that works, and some explanation of the tentative method. So stay tuned. Don't forget to like, comment, and subscribe. Thanks.